Alright, we're going to look at a full problem now for sum of forces. Now, let's assume a couple things about this vehicle before we get going. This is in fact a vehicle traveling down the road. I, on accident, put him on the left side of the road going forward, which makes him British. So we're going to try to beat the crap out of this car as much as we can. So let's assume that, just to begin with here, let's say that friction, well, we don't have to make an assumption here, friction's going to pull it back. And let's say that that friction is 2,000 newtons. Okay, and let's assume that the engine is pushing forward here, or so the engine on the car, with 4,000 newtons. Now we learned from Newton's three laws, of course, that due to the fact that the engine's pushing more than the friction, that we can, of course, find acceleration. So in order to do that, you just very simply sum the forces in the y. Now we have a positive force engine on the car, and we have a negative force friction. So all we do is we punch those numbers in for that. So we have 4,000 newtons forward minus the 2,000 newtons backward, and so it has a net force in the y of 2,000 newtons, meaning that it will in fact accelerate forward. And we find out exactly how much through Newton's second law. Acceleration is equal to the sum of forces divided by mass. So if I just take this 2,000 newtons, and let's assume that the car has a mass also of 2,000 kilograms, and that means this car will accelerate forward at 1 meter per second squared, getting faster by about 1 meter per second, or 2.2 miles per hour every second. Now let's assume a couple other things. Let's assume, as this is also happening, the car gets rammed simultaneously from both sides by two different cars. Let's assume that the car from the right hits it going this way at 16,000 newtons. Then let's assume that the car from the left hits it at about 8,000 newtons. Now again, in order to find acceleration, we would sum the forces in the x, and we'd look at that. So let's call this force of, let's call car 1 on car. This will be the force of 2 on car. So we have a negative force of 1 on car plus a force of 2 on car. And I can write this in a slightly different way than I did before. Here I had acceleration equals this, but you can see through algebra that the sum of forces, this should probably be the y here, is equal to, and that should be y as well, mass times acceleration. So I'm going to say the sum of force in the x is equal to mass times acceleration in the x, or that acceleration in the x will equal negative force 1 on car, and negative 16,000 newtons, plus force 2, which should be 8,000 newtons, divided by the mass of 2,000 kilograms, and that should end up with a negative 4 meters per second squared. But of course that's just in the x. So let's say we wanted to figure out what the total acceleration is. Well, we can see him as accelerating forward in the y, coming up this way, and accelerating negatively in the x, going that way. So we can of course just do a vector sum here. We've got 1 meter per second going up, negative 4 meters per second going to the left, and so now I just do a vector sum. Alright, and that's what I'm going to do right here. You can see do what we just did. I just made a boot. Anyway, took the acceleration in the x, squared it, plus the acceleration in the y, squared it, square rooted that to get the acceleration total, because I just have this triangle right here. There's acceleration total. And then the angle is the acceleration in the y over the acceleration in the x plus 180, because that weird, it's in the second quadrant up here. And so I added 180 to get 165 right there. And that's how you can find acceleration total. And the only thing that changes if we have like a different force is what force is going here. And the only thing that changes if you have a different mass is what's divided by here. As a matter of fact, I could quickly talk about what's going to happen if the mass were in fact, say, 1,000 or just half of that. Well, that means that's going to be twice as much because, 1,000 in there, that means that's 2. This is also twice as much. And what that means is the mass is taking care of how much inertia the object has. The smaller amount of mass means a smaller amount of inertia, which means that the object doesn't want to stay going the same speed as easily, or that it will accelerate a lot more, changing its speed quicker. This, of course, would have been 2. With having that would have made that 8. The ratio here would be the same, so the angle would have been the same, and the only thing that would have doubled right here is our final answer would have been 8.24. So half the inertia, twice the acceleration, which should make sense from this equation right here. If I cut that in half, this number should go up by 2.